In this project, we use Python and CNN to classify sport balls based on visual characteristics. Our aim is to create an accurate model for real-world application in robotics and sport analysis. Next, problem statement. First, different level of knowledge. Sport knowledge varies among individuals, requiring significant effort and passion to be well-versed in all types of balls. Next, lack of automated method. Identifying ball types efficiently is challenging without an automated method. Last but not least, similarity of the balls. Sports balls often have similar features which always lead to confusion. For the objective, this project implements CNN to solve real-life problems, enhancing image identification, machine learning, and computer vision capabilities. Next, develop a reliable Python program that accurately identifies and names different sport balls based on displayed photos. Lastly, to evaluate the CNN model's accuracy in recognizing and classifying various sport balls. For the technique used, we choose CNN for our project because it is well suited for object recognition and classification tasks. CNNs extract features from images, eliminating the need for manual feature extraction. With interconnected layers like convolutional, ReLU, and pooling layers, CNNs scan images for features and reduce processing by downsampling, making them efficient and reducing overfitting.
Next, I'll present on experiment result and analysis. This experiment was conducted using training data and testing data, and it was repeated 3 times. Based on the result of each experiment, here it shows that the images that we could match their names. However, even though the images are from the same class, they have different accuracy. Here is the output for experiment 1, experiment 2, and lastly experiment 3. For the analysis, training accuracy measures how well the model performs on the training data, but it doesn't guarantee good performance on new data. Testing accuracy evaluates the model's performance on unseen data. From the table, we observe higher training accuracy than testing accuracy, indicating possible overfitting to the training data.
For the input of this project, we have used 6 classes of ball datasets, which are billiard, cricket, golf, hockey, table tennis, and tennis ball. To implement this project, we have used 100 datasets of each ball classes, which makes the total number of 600 datasets. Okay, the first process that we implement is the data pre-processing. The code starts by setting up the necessary parameters. The image data from a specified directory will be split into training and validation sets with a 80-20 split. Next, we build on the CNN model, where it starts with a rescaling layer, then add several pairs of convolutional and max pooling layer. The pattern layer is used, and 2 fully connected dense layers are added. Next step is the model compilation. The model is compiled with the IDAM optimizer, which includes the accuracy metric is used to monitor the model performance during training. Next is the training the model. The model is trained, which takes the training and validation dataset as an input and performed for a specified number of efforts. Step 5 is the saving the model. After training, the model needs to be saved to a specified location. Step 6 will be data augmentation. To improve the model generalization and reduce overfitting, data augmentation is applied, which includes random flip, rotation, and zooming of the images. Finally, the step 7, which will be building and training the model with data augmentation. A new model with same architecture is compiled and trained again with the augmented dataset. The output of this code is on making prediction. The code will load an image and visualize it to the appropriate dimensions. The predicted class and percentage of confidence are printed, and the image is displayed. Based on the previous output, we also built a graphical user interface for the easier use of user.
Here is about how we design our GUI interface. Next, I'll show to you once we run the code, then how it will work. Alright, once you run the coding, then it will show up to you this interface. First, you have to select image by click the button, and then choose the picture from our folder dataset. For example, I'm going to choose a golf ball and pick any random picture from this dataset. Then I'm going to pick this one, and it will declare to you this is a golf ball. I'll show you another example. Click the button, select image, and then from your folder dataset, you choose a ball that you want. I will choose a cricket ball. Pick any picture from this dataset. Then I'm going to pick this one, and it will show up to you the label of this ball. Name is cricket ball. Thank you.
As a conclusion, the benefits of sports ball competition or automation saves time and reduces cost. Secondly, offers the possibilities in image recognition and computer vision. Q-learning implemented CNNs for accurate image recognition. CNNs learn features automatically. Different CNN layers extract important information. For the upcoming challenges and improvements, we have gained problem-solving experience and enhanced and model architecture.
So if our group were given more time, we wish to make a real-time object detection integration which enable live gradation. Also, we want to create a user-friendly interface for the mobile application that apply the CNN model. That's all from us. Thank you.